Hello, hello, this is Postgres FM. I'm Nikolay and my co-host is Michael. Hi, Michael.
Hello, Nikolay.
So, we will be talking today about one of my favorite topics, most favorite topics, and I think it's quite often underestimated when we grow, when our database and workloads grow. It will be about migrations, right? But what kind of migrations? Migrations is not a good term. I don't like it, but we all use it because of some Ruby guys, right? Or where did it start from? Database migrations. It sounds like we're migrating from one place to another, but actually it's about schema changes.
Yeah, so, I've heard the phrase schema migrations as well. So we're talking specifically about, and I know this is implicit in what you're saying, but I don't think everybody has this implicit, but zero downtime migration. So how do we do a schema migration in a way that doesn't block writes
schema
or reads?
Evolution.
Yeah, absolutely. Something
it's a better term,
I think. Yeah. Well, anybody that's building products, building applications, managing a database, if it has any success at all, it's going to change over time, right? You're going to want to add things, you're going to want to change things, you might even want to rename things.
3 deployments per day, as usual.
Yeah, yeah. And a lot of those changes, by default, the way that they happen take locks, right? So those locks on small tables are nice and fast, but once they start getting bigger, those locks can be really problematic. So we're talking about changes that can cause these heavy locks for long periods of time, and alternatives to those.
Or cannot acquire lock.
Yeah, absolutely. Also problematic.
This is even more dangerous, and it usually remains unnoticed until some level of workload. But I have a good recipe, and probably this recipe will work for everyone, and we will just end this episode as promised much earlier than usual when latest our episodes. So we promised not to exceed 30 minutes to ourselves and to some of our listeners, and let's try to do it. I see timer here. So recipe is simple. Let's have ID column with perfect UL ID or UUID version 7, 8, I don't remember. Some ID column, that can be integer 8. Just don't use integer 4, right? And JSON, B or without B, it depends, but JSON column. And that's it.
Well, actually, the integer 4, integer 8 question is a really good point, and the reason that's problematic is because changing the type of a column is one of these issues. It was one of these operations that takes...
I know it very well. I've earned more than 100K on it. Just on this sole task for multiple companies, at least 4 companies. So
so I think we could probably do quite a long time on that issue alone. But my main point was that it's because that requires a migration. So that is one of the category of issues here. I guess it would take a long time to discuss the details of every single one. So I was hoping we'd give some maybe newbies a little bit of an insight into what kinds of things can cause problems.
You don't understand. Let's put everything to JSON and we don't need migrations. That's it.
I understood, but I thought you were being facetious, right? We get that's the whole NoSQL argument, right? They had the marketing claim of schemaless, don't worry about migrations ever, and there's some compelling stuff in there but then the benefit of relational databases, the reason a lot of us love them is we get validation.
Let's just mention that multiple banks and financial organizations and also e-commerce organizations used this approach, JSON for everything, and schemaless, or how is it called? And it doesn't work well for data where you need good quality of your data, right? Yeah. For example, billing system. And this is on one hand. On another hand, also I can encourage listeners to read the article from Michael Stonebreaker. It was an EDB blog, co-authored with Alvaro Hernandez.
Yep.
Right. About how bad it is to avoid good normalization. So normalization, denormalization should be in our toolbox, and both, by the way. And if we talk about it, schema changes are inevitable, right? So yeah, I want to just exclude this because someone can ask, why do we need it at all? The schema changes. But right, let's start from, like, I agree with you. Let's start from something simple. You try to add a column, and
perfect example.
it's very simple column, without defaults, without anything. Like I just want some small column on the right side of my table. That's it. And suddenly you have traffic went down for many minutes. What happened? I mean, traffic to this table. It's like partial downtimes. Other tables are accessible, but this table, even selects are blocked. What happened? What do you think?
Something waiting on a lock, right? Like something gets stuck behind
yes.
that. Yeah.
I think this is something that eventually should be improved in Postgres. Right?
Like
it should
retries, or how would you?
Right. So we have created this concurrently. We have two-stage procedure to create various constraints, like foreign keys or check constraints, or unique constraints, and unique index, of course, concurrently. So we have tools to avoid long exclusive locks. Long exclusive locks are inevitable. So to adjust schema in system catalogs, at least brief exclusive lock is needed. But there are two big problems, at least two, very big problems. First, three. First is very obvious. We caused full table rewrite. For example, if you change integer 4 to integer 8, with single line, single comment, alter table, alter column, you will cause full table rewrite, and if it has 1 billion rows, probably this is when you think, oh, it's already 50% of capacity, which is 2.1 billions roughly. This is when you already start being nervous and try to do something. In this case, full table rewrite will cause very long lock, and nobody will be able to talk to this table. But this is obvious, right? We do some work while still holding this exclusive lock. Of course, even selects are not possible. There is another problem, slightly like a lighter problem, when we don't need to rewrite whole table, but we need to at least scan it at least once to check that, for example, constraints is not violated by existing rows. So it's just read, but still long, because billion rows, right? And during this, we also hold this exclusive lock. But these two problems are quite obvious. There is one particular problem which hits everyone, and we don't have anything inside out of the box or inside Postgres itself. And people just keep not noticing it until they reach some thousands of TPS. And this problem is nasty. It's like we try to obtain our log for 1 millisecond or less just to adjust our system catalogs, but we cannot because, for example, somebody read something from this table and didn't close transaction or still reading from it. Or AutoVacuum is running in non-regular mode, in transaction ID wraparound prevention mode, and in this case AutoVacuum doesn't yield, so it won't auto-kill itself. In this case we just wait to this log to be acquired, and this is easy to see in pgMustard activity wait event for our session, right? But the problem is why it's nasty. Why is it nasty? It's okay to be blocked if it's only about us, right? But the problem is we have a long line of all other transactions who try to even read from this table, and they form long line behind us, waiting if we will succeed or fail. This is it. This is our landscape of problems with making schema changes.
Yeah, I feel like you dove into kind of I know it's one of the simpler examples, but it's also one of the more complex ones, right? Like it's one of those things that looks fine in a lot of them,
Yeah, it's
A lot
simple,
of the
but
time. A lot of the time it's fine, and then sometimes it's a problem, right? It's
well,
so it's a real challenge, that one. Yeah, so well, before we move on from that one, the solution, I think you've written a really good blog post that includes this as one of the examples. So I'll make sure I link that one up. But we can there's a setting where we can cancel things that are in this example, right? Or we
lock
can
timeout
set a
or statement
timeout. Yeah.
timeout. Yeah, for example, pgRepack does it with pgRepack does something like that, and it uses statement timeout.
Okay.
But it's old school, old-fashioned way, because it will affect also DML and so on. There is lock timeout, statement timeout. If you do it in your session, if you have quite complex transaction, very properly organized, so all logs are closer to the end, because logs, all acquired logs will be held until the very end of transaction, rollback or commit. So in this case, if you use statement timeout, it will be applied both to DDL and DML, including selects. So there is a finer gray, how to say, a special timeout, fine-grained setting, which will be applied only to lock acquisition, not to whole statement duration. And it's called lock timeout. And of course, I prefer using it. I don't remember what pgRepack decided. They originally said, oh, we need to think. When I proposed to use lock timeout, because statement timeout, it was not working well in some cases with pgRepack. I don't remember details. It was long ago. But lock timeout is what you can use at least to not to block others for long, because if you are being blocked, not being able to acquire lock, you block others. At least it can be like, okay, half a second, right? Why so? Why this value? We had our first episode about query duration, latency, what is long, what is short for human perception in OLTP case, web and mobile apps. So second is already very noticeable, but half a second or maybe 100 milliseconds is quite good, but depends on the cases. Maybe you try, but you fail, and you need retries. And in my article, I have another article about it, right? Specifically for this problem, proposing the solution, retries and low log timeout, maybe increasing with some back off jitter and so on,
Yeah, sometimes people call it like exponential decay, like that kind of.
Right. But not until hours, right? Not until minutes even. It's still quite limited, and maybe try a bit later and so on, and be prepared for your deployments to be failed. It's fine. If you have auto vacuum processing, well, it also depends. I see some people prefer observing auto vacuum running in this mode, understanding that it kicks off early, like at 10%, 20% usually, it depends, of all capacity. It's very safe to just terminate it and let it restart later. But if you terminate it, your session should be already in process of attempt of acquisition of lock, because if you just terminate and go try, I bet auto vacuum will be sooner than you, and you will have the problem again. So you need to start attempt and kill auto vacuum, pg terminate backend for auto vacuum, and then it frees, it opens the road in front of you. Right, but I wanted to mention, you're right. This is one kind of a problems when you think it's so simple, everyone hits it, at least like silently, not noticing until some level of workload. So simple, but it's also complex under the hood. If you dive inside, it's like many things. But it's so simple. How come people live without a solution to it? And it still amuses me, actually. So I don't understand why. We definitely need something, but I have solution at upper level outside of Postgres. But I think at some point inside Postgres should be done something. We see some improvements in the area of partitioning, like detached partition is is already not blocking and so on. Many things like that. But this is just let me add a column gracefully, right?
Yeah.
I would like to specify Locktimeout and number of retries, some logic right inside this alter table statement. Proposal, right?
Yeah, that's an interesting idea. I always think, how can you make these things the default, right? Because until you know that those settings exist, you're still going to hit that the first time. But yeah, it would be nice to empower people that do know it's an issue as well. Just wondering
Sorry. Sorry, I promise not to interrupt. Sorry. I'm listening.
No, okay. Let me try. I'm wondering how we can help people who don't even know it's an issue. So, like the people, I've come across really experienced engineers. Some people that I consider some of the best engineers I've ever worked with. And for example, this was, I think, it must have been pre-Postgres 11, but somebody adding a column with a default. So they that was always going to cause an issue, and it did. So that was a real problem.
This
but it
falls
caught them
into.
out.
Sorry, I'm interrupting again. It falls into previous. Like we have table rewrite, table full scan, and this like unsuccessful lock acquisition problem, right? What you mentioned, it falls to full table rewrite because pre-Postgres 11. When we create a new table with default, it caused full table rewrite. This I would expect. I understand this is like the Postgres is not perfect here. I understand this, okay, but that I like what? Like how come?
Okay.
Even simpler example. I want to drop a column. Same. Same.
There's some. I'm conscious we're not going to have time to discuss every single case of this. So there is a couple of good articles. One on the one I just mentioned on it was by Branda, wasn't it? On adding on the change in version 11. And I think the nice thing about that article is it goes into some of, not all of the complexities. He does link to the patch, for example, but how complicated some of the remediations needed to be to make adding a column with a default not a rewrite case. So that changed in version 11, and it's not trivial, that change. There's a lot of places that touches. So I do have sympathy with that. These things are difficult to do, and difficult to do in a way that still lets people on simple databases just get things done. So I understand like the complexity, but equally it would be nice to not have people shoot themselves in the foot quite so often as happens at the moment.
Right, and actually this change in Postgres 11 is very connected to integer 4 primary key problem, because if you think about how you can convert to integer 8, there are two big approaches. I call it new column and new table. New table is more like pgRepack style, when you need both should be zero downtime, right? The second one, new table, it's more like pgRepack style. You need to create another table, but first implement triggers that will record all changes in some delta table, and then you do create table as select, or just copy like some snapshot of existing table. And then you actually, there are interesting tricks there as well. And then you need to take care of about indexes, constraints, foreign keys especially. It's interesting, very interesting. And then you apply delta maybe in several steps. Actually, it's possible to split it to multiple transactions, which I didn't know initially. I thought, whole delta needs to be applied at once. No, pgPack it's much smarter. We can do in steps. Just last step should be inside our renaming transaction. But this is more complex approach than just new column.
Yeah.
But if you do new column, eventually you need to redefine primary key. But primary key, okay, primary key, not only in Postgres, in Fear even, it consists of two things: uniqueness and not null. Two constraints.
Yeah.
Uniqueness, we can create index concurrently with create unique index concurrently. It might fail if there are duplicates. We fix it. Eventually, we can create it without long locks. So it's like so-called online operation. So create index concurrently is online operation, and create unique index concurrently. Create index is not online operation, not how to say, online safe, or there should be some term for it. Zero downtime, it's not proper term, because if we block one table, it's not downtime. I call it partial downtime. Only some part of workload which deals with its table is experiencing problems, but everything else is fine, right? So
I like online operation as
yeah,
sounds good.
A good friend of mine who is from SQL world, a good, very big professional, gave me this term. I like it as well, online operation. So but what about not now? Before Postgres 11 is terrible, absolutely terrible. You cannot create it. Period.
Wow.
So, yeah, if you create it, you have second type of our problem. You need a full scan. Postgres needs to fully scan table at creation time, and during this time it holds this very expensive exclusive lock. But and check constraint can be done in two phases. So first you say not valid. You create check constraint very fast, not valid. Again, you need to do retries. If you do it very properly, you need retries and because it's still changing schema, right? But not valid means it will not be applied for few. Some people think not valid, it's not valid. Like, no, I mean, it's not valid for all data, but it's already being checked for all new rows, updated or inserted.
It's like no validation rather than not valid.
Right.
Is that fair?
Right. Yeah, it's already working, but we skipped validation for existing rows. And then we in our transaction alter table validate, and this doesn't need the long lock. Constraint already there, it's just a flag, and this is like two-phase, two transactions, separate transactions, and this is how we can mark it. We can create a check constraint. Our new column is not null. But before Postgres 11, if you create check constraint, it cannot be done in two phases. I think since Postgres 12, if there is check constraint and then you create not null, it's smart enough. I think Sergey Kornilov implemented this. It sees, oh, there is check constraint is not null, so I can rely on it. It already validated all rows.
Oh.
And it skips it in Postgres 12.
That would be cool.
But using some brain power, we solve the problem for Postgres 11 as well. What we can do, we say, because just relying on this new feature, non-blocking default, when we create our integer 8 new ID, we say default -1, not null.
Yeah. Or, yeah.
And it's magic. Like Postgres thinks, oh, it's this -1, this default is virtual. Postgres doesn't rewrite whole table. It just says, okay, for all existing tables, we think it's -1 virtually, right? But if it's already filled with some, we can say not null, right? Then we backfill in batches and drop default. -1 goes away. We have real values. That not null is there. So this trick we used for Postgres 11. It's funny. It's like very interesting. Like this is like, it feels like art. You used what you have to achieve something. Like multiple things work together, and you achieve something very useful. But then I even was slightly disappointed in Postgres 12 seeing this, like, okay, now we can do just check and then in two steps. Then we create not null, regular not null, and this interesting trick is not needed anymore. So
yeah. I know it's not a good analogy, but I quite like thinking about it as if you ever seen those magicians putting lots on the table, like a dining table, and then they get the tablecloth and then they whip it out and with everything stays as it is. A good migration is a bit like that. There's always one step at the end that's kind of like the little finesse, the last little thing to make everything work. But it needs to be really quick, and it needs to be like not change anything. But it can all go wrong as well. So if they pull the tablecloth and you haven't quite sorted everything out, everything falls on it. Everything smashes, basically. So yeah, that's a really good example, and I think we've got some. There's one other blog post that discusses some of that in more detail, which is the Braintree one. I think they've updated on the PayPal blog, so I'll link that up. That has some of these kind of worked examples in it. Another one I did want to make sure we covered, or at least I think that's on the slightly more complex side, is one that one of my colleagues covered from GoCardless that caught them out, and I think you cover really well in your post, but is not obvious, which is the foreign key updates. So like the fact that that it takes locks on both tables, I think is really like
different locks. And if also if partitioning involved, it's very interesting. I cannot it's very interesting. And let me also advertise a couple of things. First, GitLab has very good migration helpers if you use Ruby, and if you don't use Ruby, it's still very insightful. It's their source code, and they have very, very good documentation about all these things. So it's very well tested both on their production.com and all GitLab instances. There are so many of them, right? And you need to deploy without seeing what is happening, so fully automated. And sometimes tables are huge, even if it's not their .com. So it's very challenging task, and they solved it. So their experience, I find their experience is very one of the best in this area for Postgres. And also, of course, our tool dblab. So if you deal with foreign keys on both sides, sometimes we need different types of logs. Fortunately, we can create foreign keys in 2 steps, but if partitioning is involved, it's tricky how foreign keys are propagated from parent to partitions, from main table to partitions. I never keep it in my mind. It's too much. I trust 2 things. First, documentation and source code, and second, our tool. Our tool detects long-lasting exclusive logs. You just need to apply it with either for existing tables taken from production without PIR or something, or just raw production. It's even better if you can afford it in terms of how infrastructure is organized. Or you need to generate some rows, right, for testing. And by the way, today I just used ChatGPT to fill tables. I had some rows in my table, and I needed to have more, right? Okay, I have 1 megabyte. I want 1 gigabyte or 100 gigabytes, and help me. It's good in this if you show examples, and it helps you increase the size according to some patterns we already have. So if you just test with big data, our tool can catch. Database Lab engine, dblab, can catch long-running exclusive logs, and in this case, you understand your solution is not good, and you go fix it. I think these things I trust, right?
So this is great for catching. Yeah, this is great for catching 2 of those classes, right? Including let's say it's a large table, but it's the third case is still difficult, right? Because as in the GoCardless blog, you need to have some long-running transaction or vacuum, as you said, something
You're absolutely right.
And it's still tricky. It still catches. So I'm not sure if maybe the GitLab one does warn for that as well, but I think that's actually super tricky.
Migration helpers GitLab has implement this approach. Nice. Low log timeout and retries. They have it. They have helpers for this awesome. Thing. But you're absolutely right, and our tool right now doesn't do it. We don't have background transactions which do this. It's technically possible. Yes, we can think about it, but so far this is something you need to do, and so yeah, we cover only 2 first classes. You're right, but for this, I think everyone should just needs to have it. Always, be prepared for long-running, after vacuum or some transactions holding some even share logs blocking our DDL. So We didn't cover actually interesting topic how DDL is related to DML in like updates or deletes in batches, or like massive insert as well. Also interesting. There are many things, right? And we have already reached our limit in time, so let's wrap up. I think we scratched surface, but we did well because we brought many good links on the table, right? Articles and so on, materials.
Definitely. And I think we've given some good warning signs. You know, if you're thinking about adding a column, if you're thinking about adding an index, anything to do with partitioning, create, detach, we've given some good warning. Oh, foreign keys especially. Anything around renaming. These things are scary, and you should be careful and try and remember this and read up about it.
Renaming has issues also related to application, because if you have many application nodes, it's also interesting. Sometimes you cannot simply rename. Yeah, well, it's interesting. The topic is very broad, and warnings are right, and just like I bet most people have issues in their database migrations they have. Like they just don't. If you think everything is all right, you just don't have proper cases. You haven't met problems yet. Because there might be problems lasting a second and nobody noticed, right? But later it will be 10 seconds, then 1 minute, and it's already bad. So I hope it was helpful. Please read articles. A lot of wisdom there, and all we mentioned.
Yeah. Brilliant. Nice one, Nikolay. Thanks so much, and catch you next week.
Yeah, thank you all listeners. Let us know if you like shorter episodes. Okay,
nice
bye.
one. Take care. Bye.